Well, hi everybody. Welcome back to another one of the Half Earth Project Educator Ambassador Chats. I'm really excited today that we have a super special guest, Corrie Moreau. Hi Corrie, how are you doing?
Great, I'm thrilled to be here.
Yeah, that's great. So glad you could make some time for this. Um, you'll learn about Corrie as the discussion goes on, but Corrie is um, I'm excited to have Corrie on for a bunch of reasons. One is she's a killer biologist who is also an entomologist and ant expert, but also has had throughout her career has really proven herself to be a great science communicator. So I think you're all going to really enjoy getting to know Corrie a little bit. Who could this be?
Yeah, so I was very fortunate to have as one of my PhD advisors, E.O. Wilson. And in fact, I think I was his last official student. And he has, of course, had a huge impact on me, both in the way that I think about ants, but of course, how I think about biology and conservation and science communication. So I'm currently the Martha N. and John C. Moser Professor of Arthropod Biosystematics and Biodiversity at Cornell University. That's a mouthful. But in addition, I'm also the director and lead curator of the Cornell University Insect Collection. So I wear a multitude of hats, but my scientific career actually starts much more modestly. I grew up in New Orleans, Louisiana, and fell in love with biology at an early age and absolutely loved nature, but didn't have a lot of nature around me. So I went out and looked at whatever wildlife I could find, and the ants in the cracks of the pavement were what really captivated me. And I was fortunate enough to go off to university in San Francisco State, where I got to major in entomology and evolutionary biology, and started my scientific career studying ants there. Before I went off to Harvard to do my PhD with, of course, Ed Wilson and Nomi Pierce, where I tried to understand the sort of deep evolutionary history of ants using molecular data. And those are some of the tools I still continue to use today, is any kind of DNA and genomics to sort of understand why there are so many species of ants. Why do they engage in such interesting behaviors? How do they distribute across the globe? So those are the kinds of things I try to do in my research program.
And do you find, obviously you can be interested in ants just because you are, but for these questions about evolution and adaptation, why there should be so many different species, are ants particularly good for those sorts of questions?
I mean, I would argue yes. I mean, part of it is that, I often get asked the questions like, why would you focus so narrowly just on ants? But it turns out there's more species of ants than all the birds and mammals added together. So
Right.
that remarkable amount of diversity isn't just numbers, it's actually, changes in their anatomy. And we can actually look, just in these two different species here, you can see that they're very different. The ant on the mango, that's Attosextans. So these are the ones that are the leaf cutters and the fungus growers. They sort of march around cutting up bits of things to feed to their fungal gardens. And the ant on the right on the leaf, that is Cephalotes varians. It's one of the species of turtle ants. And these so one's living in the ground and one's living entirely arborally. So we can ask questions about how does where they live affect their diversity? We can ask questions about their diet. So when they feed on different kinds of food sources, does that impact their diversity or their distributions? And even we study their gut microbes. And we ask the question, do gut microbes actually help them shift onto novel diets?
Hmm. Wow, a whole group called turtle ants. I didn't know about that. That's cool.
Yeah, it's my favorite group of ants, actually.